Alright, so we're going to be graphing quadratics. So, first thing we need to think about is that we have three different forms of quadratics. Standard form, ax squared plus bx plus c. Vertex form, a times the quantity x minus h squared plus k. And factored, x minus something or x plus something times x plus something. So those are the forms we've talked about. To find a y-intercept, you set x equal to 0 and solve for y. So you just plug in 0 for x, and it's going to be, it looks like 0, comma, some number. For x-intercepts, we do the opposite. You set y equal to 0 and solve for x. And when you set y equal to 0, you have completing the square, factoring, square root property, or the quadratic formula. And you're going to have two x-intercepts, or solution, or 0, where these all mean the same thing. So you're going to have two, a number, comma, 0, and a number, comma, 0. And our vertex, you can complete the square, or you can use the shortcut when it's in standard form, negative b over 2a, and then you plug that in and get the y value. So if we're looking at, and again, when we're graphing these, we need the key points, so our intercepts and our vertex, labels on both axes, and scale each axis appropriately. So I'm kicking a soccer ball here. So if we want to find our vertex, do our shortcut. A is negative 4, B is 16, C is 0. We don't have just the number by itself. So it's negative 16 over 2 times negative 4. It's negative 6 over negative 8, or negative 16 over negative 8, which is 2. That is our x-coordinate of our vertex. And to figure out our y, we plug in 2 for x, or in this case, t, and we get that y is 16. So that's our vertex. To find our y-intercept, you set x equal to 0, or in this case, t, because x is actually t and h is our y. So we plug in 0, 0 squared is 0, times negative 4 is 0, plus 16 times 0, that's 0. So our x-coordinate is 0, and our y-coordinate is 0. Then for our x-intercepts, we set y equal to 0, which is what we're doing right here. And then we're going to solve this. Factoring is the easiest way to do it. We take out a 4t, our GCF, and set each one of those equal to 0, and solve for t. So t is 0, and t is 4. So again, that's our x-coordinates. Our y-coordinates were 0, because that's what we set them to be. So we have our 3 points now. And we just want to make sure that we have enough room on our graph to put everything. So our biggest y value is 16. So I went up to 20. And our lowest was 0. Our x's, our lowest was 0, and our biggest was 2. So I just went up to 4. Or, sorry, is 4. So we need to make sure we have both of those. And then we just connect those 3 points, making a U shape, because that's what our parabola is. Looking down at this next one with the garden, our vertex, well, this isn't in standard form. So what we had to do is FOIL this and combine like terms to put it into standard form. A is 1, B is 17, C is 70. So it's negative B, so negative 17 over 2 times A, 2 times 1. Negative 17 divided by 2 is negative 8.5. That's our x-coordinate. Our y-coordinate, you have to plug that back in for x and get our y, and our y is negative 2.25. So that gives me my vertex. Then, if I want to find my y-intercepts, I set x equal to 0, plug it in. So 0 plus 7 is 0 plus 10, which is 7 times 10, so 70. I set x equal to 0, and my y was 70 when I did that. My x-intercepts, well, it's already factored, so we don't have to factor it. We just set each one of those equal to 0, solve for x, x is negative 10 and negative 7, and our y value is 0, because that's what we set it equal to. That's how we solve for it. So we have our 4 points here. So looking at our x values, we went from negative 10 to 0. So we really only needed one axis here. But we went negative 10, and I went up to 6. Then we looked at our y values, and went from negative 2.25 to 70. So we went a little bit below, and we scaled it by 10. Then we just connect the dots when we plot them. And we get something that looks like this. And we're just sketching it. We're just having a rough thing of what it looks like.